Okay, let's look at some examples from the 5.5 homework. And I want to start with number 2. Number 2 gives me a probability density function, and it wants me to find the expected value, e of x squared, the mean, the variance, and the standard deviation. Remember, that was the first thing we talked about in the concept videos. I can actually use integration to solve for these different things given a probability density function. So how do I do that? Well, let's start with e of x, right? The expected value. I can find that by integrating the probability density function over its entire domain, so -4 to 4, with an extra x multiplied on. So I get x times my probability density function, 3 over 128 x squared dx. This doesn't look too pretty, but remember that multiplication is commutative, so I can go ahead and multiply x and x squared together and get x cubed, but I can also pull that constant out in front of the integral. And now I'm ready to find an antiderivative. Now that I have my antiderivative, I can plug in my bounds. Don't forget that when I plug in -4, I'm raising that whole number up to the 4th power. So when you plug it in your calculator, make sure you use parentheses. Well, when I do 4 to the 4th divided by 4, I actually just get 64. Because I think it's 256 divided by 4. And then over here, when I take this negative number to an even power, it's going to become positive. And so I get 64 minus 64. Interesting. So what does this end up equaling? It ends up equaling 0. My expected value is 0. Pretty cool. But if you think about this distribution function, it actually makes sense. My bounds are symmetric. I'm starting at -4 and I'm ending at +4. And an x squared function like this, if I don't have anything added to it, it's also symmetric. And so it makes sense that the expected value would be right in the middle. So there's e of x. Now it wants me to find e of x squared. Well, this is the same exact process, except instead of adding an x to my integral, I'm adding an x squared. I can simplify it in the same way, but now my antiderivative is going to be slightly different. I'll plug in my bounds, and I get 1024 over 5 minus a negative 1024 over 5. So what happens when I subtract a negative? It becomes addition. And I get 2048 over 5. Well, 128 actually goes into 2048, so this actually simplifies kind of nicely. I get 48 over 5. And that's my e of x squared. I'm actually going to go ahead and write that as a decimal. It's 9.6. And now I'm ready to figure out the more applicable values. What's the mean? What's the variance? What's the standard deviation? Well, all of these can be solved for using these values that I just calculated. The mean, of course, is just whatever the expected value is. So in this case, 0. The variance, if you remember, has that formula where you just find your e of x squared minus your expected value, or just e of x squared. And so in our case, e of x squared was this 9.6 minus my expected value, of course, was 0. 0 squared is still 0, and so I get 9.6. My variance is just 9.6. Well, your standard deviation is just the square root of the variance. So I get the square root of 9.6, which is equal to 3.098. Perfect. So what's nice is with this one, I didn't have to use integration by parts because my probability density function was just a squared function. But I found e of x, I found e of x squared, and I used those to calculate the mean, the variance, and the standard deviation. Okay, let's look at the next problem. This is number 5 from the homework. And in this one, we're dealing with a normal distribution. So now we get to use what we learned about with the normal distribution. And you'll notice that in this example, it doesn't give me a mean or a standard deviation. And that's because it uses this word right here, a standard normal distribution. Well, with a standard normal distribution, we just assume that the mean is 0 and the standard deviation is 1. Why is that significant? Because remember, in order to be able to calculate any sort of probabilities or areas, I need to find z-scores for my data. Well, if these are my data values, And if my mean is 0 and my standard deviation is 1, notice what happens when I try and find my z-scores. If my data value is 1.28 and I minus the mean of 0 and divide by 1, I just get 1.28. So with a standard normal distribution, if my mean is 0 and my standard deviation is 1, then the data value it gives these also count as z-scores. These are your z-scores right here. Now, it gives me 2 z-scores. So therefore, if I go back and use this table from earlier, that's 2 different areas that I'm looking up. How does that work? Well, the way this is going to work is, let's draw a picture to help me out. So here's my normal distribution. Here's my mean of 0. And once again, I've got these 2 z-scores, 1.28 and 1.85. And based off what I understand of probability density functions, what it's asking for is it's asking for this area in between the two. If I had a probability density function, I could do this by calculating the integral between 1.28 and 1.85 of my probability density function. But once again, the problem is that this is a normal density function, meaning it's impossible to integrate. So I have to use my table. Well, let's go up to the table and let's find my corresponding areas for these 2 z-scores. The first one was 1.28, so I'll go down, find my 1.2, and then find my hundredths place of 0.08, and then find my corresponding area. So that gives me an area of 0.3997 for that z-score. Well, I also need to do this for the z-score of 1.85. So I'll come over here to 1.8, get my hundredths place of 0.05, and that gives me this area, 0.4678. So now I have 2 areas for these 2 different z-scores. How does this help me get my answer? Well, the way this is going to help me is for me to be able to actually visualize what these areas actually represent. So if I come down here, that 0.3997 represents the area between my z-score of 1.28 and the mean. So that's this area right here. That's the 0.3997. Well, that's not the area I want, right? So let's move on to the other one. The 0.4678 represents the area between my mean and 1.85. So it represents this whole area right here. So how do I use those 2 areas to find this area? Turns out I can just use subtraction. I can take that 4.4678, the bigger area, and subtract the smaller area to get the area in between. And I get 0.0681. So that right there is the area between the 2 z-scores. And that's how a lot of these normal distribution ones are going to work, where there's going to be 2 areas that you're working with corresponding to 2 different z-scores, and you just have to decide, are you going to add those areas together or are you going to subtract the areas? But that takes care of number 5. Okay, the last one I want to go through is number 9. And this is our good applied problem. So we have an online vendor of UCDs that the number of orders that they receive every day ends up being a normal probability function, or normally distributed. And you'll notice that with this problem, it gives me a mean of 270 and a standard deviation of 20. So in this case, we're not using that standard normal distribution where my mean is 0 and my standard deviation is 1. I have a specific mean and a specific standard deviation for this situation. So now let's look at what this is asking. The company has to hire extra help or pay overtime on those days when the number of orders received is 314 or higher. What percentage of days, or what's the probability that the company will have to hire extra help or pay overtime? What does that mean I'm looking for? I'm looking for the probability that the number of orders, which that's what X will represent, that the number of orders is greater than or equal to 314. Because if that happens, then they have to pay overtime or hire extra help. So that's what we're concerned about here. So what do I do with this? Well, this only gives me one data value. Once again, I can't just use that in my z-score table. I need to convert this to a z-score first. So I'm going to go and use my z-score formula, which of course is my data value minus the mean divided by the standard deviation. So in our case, the data value is 314, the mean is 270, and the standard deviation is 20. This gives me 44 over 20, or 2.2. So I now have a z-score for this data value, and I can go ahead and come on up here and find the area for 2.2. So I'm going to go to 2.2 on this side, so there's 2.2, and since I don't have a hundredths place, I just use the hundredths place of 0. So there's my value, 0.4861. Now this is where we have to be careful, because if we just don't think about it too much, we might put this in as my answer and we're going to get it wrong. And that's because, once again, this area represents the area between my z-score, which in our case is 2.2, right? It's going to be on the right side of the mean. It's between the mean and that z-score. Is that what this probability is asking for? No, this probability is, what's the probability that we get a value that's bigger than this z-score? That's bigger than 314. So I'm actually looking for this probability. Well, how do I come up with that probability? Well, remember that one side of the data represents 50%, or 0.5. So this whole thing right here is 0.5. But if I only want this very edge here, everything outside of the 2.2, everything greater than the 2.2, what I can do is I can subtract off this area of 0.4861 to take away this red area. And that gives me 0.0139. And that makes sense. If the mean is 270, if the average is 270, then the likelihood of getting 314 or more should be relatively low. And that's what this is saying. There's a 1.39% chance that the company will have to hire extra help or pay overtime, right? That's the percentage of days that this situation will occur. So you'll notice how this was similar to what we did above. Even though in this case I only had one data value to work with, I still had to think of two areas that were going to be helpful, and then I had to make a decision about whether to add or subtract. In our case, one of the areas was 0.4861, which I got from finding the z-score for my data value. But the other important area that was helpful was just this area of 0.5, representing the second half of the data. And then I subtracted those to get this tail end of the data over here. But that takes care of the examples that I wanted to go through for 5.5. If you still have questions on the homework, where there's a lot going on in this homework, so that I would completely understand, please shoot me an email or come in during office hours, and I'd be happy to help you with any of those. But that takes care of 5.5, so good luck with the rest of the homework, and I'll see you in the next video.